This video will give you a brief overview of how to analyze motion graphs. The first motion graph we're going to talk about is a position versus time graph. If you analyze the slope of a position versus time graph, you will be able to learn a lot about the velocity of your object. For example, the slope of this first graph here is 0. Therefore, the object must not be moving because it has a 0 velocity. If you look, as time goes on, the position is not changing. Over here, we have a constant slope, therefore a constant velocity. The distance that is traveled each second is the same. In this particular graph here, when you have a curve, we see that the slope is changing as time goes on. Therefore, the amount of distance that is being covered per each second is changing. So we are either speeding up or slowing down. If you see that the slope is increasing as time goes on, then you have an increasing velocity. You're speeding up. If you start horizontal and you get more vertical with your slope, then you are slowing down. Our next graph is velocity versus time. If you have a line sitting right on the x-axis or the origin, that means that you have a velocity or an acceleration of 0. You have a 0 velocity and you are not moving. If you have a horizontal line, that means that you must have a constant velocity. As time goes on, your velocity is not changing. We have a slope of 0. The slope of a velocity graph is the acceleration. For this third graph, you start at 0, and as time goes on, your velocity is increasing. Therefore, you must be speeding up. So if we just take a look at the slope of the velocity versus time graph, we can learn about the acceleration. Our final graph is our acceleration versus time graph. And for our purposes in Physics 1, we're only going to cover constant acceleration. So the only graph that we have to worry about is this one right here. When we see a horizontal line, that means that you are speeding up. It means that your acceleration is constant. If you are accelerating, you are speeding up. If we put it all together, we can start here with this position graph. We notice that the slope starts out very shallow and increases as time goes on, meaning we must be speeding up. If we look at this, that shows speeding up. Starts at 0 velocity and increases as time goes on. If we look at the slope of the velocity graph, we see that it is constant, which we again see represented by our acceleration versus time graph, a constant acceleration. These arrows, if you just draw this little diagram, you'll always remember that the slope of a position graph leads you to velocity. The slope of a velocity graph leads you to acceleration. Here's an example for you to check your own understanding. Based on this position versus time graph, draw the velocity versus time graph. And let's check your answer. There you go. So we start with a very steep slope, meaning that we're starting with a high velocity and it's flattening out, going to a shallower slope. So therefore, we must be slowing down. We start at a high velocity and end up down there at a low velocity, slowing down. Thanks for watching.